Okay, our session's being recorded.
So good evening, guys, and my name is Yelena. I'm one of the Data 610 TAs. So today we're going to do a brief introduction to R and R Studio that you're going to use for your assignment 4. So you might be wondering, what is R? It's a statistical programming language that was developed in New Zealand, and it's basically a command line interface. Now here you're going to have the slides posted in the classroom. So basically, there are some advantages of R, which is free. It's an open source. It means that the developers can add functionalities, and you'll see what it means as you start learning R. And it has excellent data visualization capability, and it has advanced statistical methods that you may see later on in the program. And you may also save the commands to reproduce the results, and you can share your results with your team or your coworkers, so to speak. Here we have some drawbacks. So basically, you would need to practice the commands to get comfortable with it, and you need to learn how to read the help pages, and I'll show you how to do that. And then we need to keep in mind that our language is case sensitive. Lowercase x is not the same as an uppercase x, and R may or may not solve all the data mining problem, and you need to keep updating your packages regularly, and including R itself. Usually they have a new version every 6 months approximately, so you would need to make sure you have the latest version. Now, RStudio is basically an integrated developer environment. So, and I'll show you how it looks like shortly. And basically, it has a nice toolbar menu that you can use, and you can preview environmental variables. I'm going to show it to you shortly. But before I do that, I want to point out that there is a free course, Introduction to R, and this is free, and it's offered by Big Data University. And it's the same course where you may have taken an introduction to Watson Analytics. Most of you have taken it. And this is another one, Try R Code School course. It is absolutely free, and I think you're gonna like it because it's interactive. And you basically get an opportunity to practice the commands as you study, it's introduced, right? So here we go. This is a page where you would need to install R first, then RStudio. And I think I have that page opened in another browser. Here it is. So this is the R page, right? That's where you're gonna go and download, and instructions will be provided in the classroom. And you have download for Windows, and you have a download for Mac. Okay, and after that, you're gonna go in here, and you're gonna download the RStudio. All right. So, and instructions are gonna be in the classroom. So now here it is. Once you download it, you go into double click on a shortcut to launch the program. And what you're gonna see, you're not gonna see this source code open. You're gonna see 3 panels. 1, 2, 3. Right? So you're gonna see the 3 panels, and I'm gonna show you what it is. Here is a console window. This is a window where you're actually going to type the commands. Right? You're gonna be typing your commands. The output is gonna show here. Any error messages or any warnings are gonna show in here, in this window. So you're gonna use this window a lot. You're gonna be typing your commands, right? And in fact, I can just show you what I mean. I can use R as a calculator. 2 plus 2, 4. So basically, this is what this window is for. Now, I'm gonna go to this tab. Here is a history. Well, I was doing something before. It still saved it from last session, but if you can see this here, it has my commands that I ran, and I can do this. I can click to console, and that's how I can repeat. It's nice. It saves me some typing, right? So here is the history. It saves the commands that I ran, right? It's a chain of commands. So that way I don't have to retype it. I can just go here and click to console. Now here is environment. Right now it's empty. What it's going to be is when I create some variables or when I load some data, and I'm going to show you what I mean, everything in here will be listed. Like, for example, if I define the variable x, right, it's going to be listed in this panel, environment. Now, x, let's suppose we want to define x and we want to set it equal to. This is an assignment operator, right? This is an assignment, less than sign and dash 2. So I created a variable, x, and I set it equals to 2. Right now I don't have any output because what I did was I just set x equal to. This command does not show an output, but if you look at it right here, I created a variable called x, and this is a value, right? So this window is going to show me all my variables. Now, if I no longer need this, but you need to be careful with this. This is a broom, and if I click on it, it's going to clear everything that I have here. Well, in this case, I want to do this, and you're going to be prompted. You're going to say yes. So I deleted, I cleared up everything. And sometimes the reason is, suppose that you have a bunch of stuff here that you don't need anymore. You may want to delete what you don't need because you want to keep the space empty. You don't want to take up too much memory, right? Now another thing, look at this. I'm hitting. You're not gonna see what key I'm hitting, but there is an up arrow on your keyboard. And when I do it, it shows me the previous commands. So that's another way, and it shows you a lot of time. It saves you a lot of time too. So I created my variable x again, and this is another way how I can remove something from memory. The command is rm, right? It's gone. So because sometimes I have more than one variable in here and I want to remove it, I don't want to hit my broom because it's going to get rid of everything. Now, here you have files tab, and this is going to show you the files that are in your current working directory. What's a working directory? It's sort of like a default folder. If I want to list my files here, it's going to show me the files from the folders that I have it set as a default, right? If I want to save something, this is the initial folder where it's going to look at, right? So, like, for example, let me give you an example. If I want to, I'm going to go over it, but what I'm trying to see here, see this? If I want to load the data, it's going to go to this PC document. So, current working directory is the default folder, and I'll show you how to change it soon. So that's what it is. It's listing the files in the current working directory. Here, plots. Right now, I don't have anything because I have not created any plot yet, but we will. Packages. All functions in R are defined in, they're grouped together in something called packages. Some packages come with software installation, and some packages are not. You would need to install it. For this class, you may or may need to install. I would need to look at the assignment again, but I believe you may be able to do the assignment without installing anything, but I could be wrong. Alright, so basically anything that you installed is a user library. Notice that there are two sections here. And there is another section where here it is, it's a system library. So everything from here down, it comes with RStudio installation, and everything up there is what I installed. Right. So now help, this package, this page is your friend. Trust me, you're gonna like this section here, because when you're not sure what the command does, what you could do is, suppose that I don't know what rm does, I can put question mark and type the command name, and it's going to show me, over here, it's going to show me what the command does. So it's showing me the package the command is in, which is base, and it's going to show me what the command does, when would I use this command, and it's going to show me the parameters, the argument that the command takes. In this case, it's a variable name. Or I can also put a list of several variables in there. Alright? So we're going to go back to our slideshow right now to make sure I don't miss anything. So we went over this. Oh, another thing that I want to point out, guys, on this slide right here, it says R version 3.23. The latest version now is 3.24. It's a recent update, okay? So some of you may ask me, wait a minute, it says 3.23, but the web page where you install R says 3.24. So install the latest version. We went over this, and now I went over this part, right? And we went over the slides. Okay. And I'm going to show you how to do the chart shortly, but what's basically happening is the plot stop is going to display the chart. And you have arrows. You can navigate between plots. Suppose that if I plotted more than one visualization, I can navigate, and I can save my plot in a PDF file or as an image file, and I can delete. Or again, we've got a broom here. What that will do is it will delete all of the plots. Okay? So you want to be really sure before you do that. So we went over the help page. R syntax. Now, R is case sensitive. This is very important to remember. Spaces, the number of spaces does not matter. That's mainly for the readability. So what I mean here is that if I do 2 plus space 2, it does not matter. I still get 4. That's what I mean. Right? So now you can have functions may have required and non-required input arguments, and I'll show you that also. When the values are missing, well, very often you're going to have a data set where the values are not specified, right? And they're represented as capital N, capital A. Now here, some variables can have a value true or false. So here, capital false is same as F. Capital true is the same as T. But again, keep in mind this is all uppercase, right? So lowercase true and uppercase true are not the same. All variables are treated as vectors, even if they have only a single value. Note that here, this is only one value, but it's showing me that the first element of X, it's treated it as vector. Even though X has only one value, R thinks it's a vector. Like here, see? Now we're going to go back. This is an assignment operator, and also R supports regular expression. It's a little bit more advanced, but okay. So now we're going to continue here, and I'll show you that we can do assignment, that we can do the calculator. Right, so you can do the division, you can do the power, you can do subtraction. All right. Oh, and also we can have the string values. String values are going to be in a double quote. Like, for example, let me do this. I'm going to create a variable called y, and this is an assignment operator, and I'm going to set it equal to Yelena. So here it is, and there is only one value, Yelena. Now, suppose that I want to have a list, right? I want to create a list. That's what you do. To create a list, you do this. Suppose that I have a variable. Well, usually you want to use something descriptive, but this is just for demonstration. To create a list, you use this C. It will create a list. And in parentheses, you're going to specify the values. Right, so I'm gonna say Yelena, then I'm gonna say Steve. Well, sorry if I misspelled, but I'm a bad speller, and I'm gonna say Tom. Okay. So I've got this, and I'm gonna hit enter. See this? What it did is it created two elements, right? I created this list with three elements, rather. And why is it important? You'll see that because some functions that you do, they take a list as an argument, right? So what I could do, I could just print this, output it to the screen, or what I could do is, suppose that I'm interested in only one element, right? So I'll do this, z of 1. So this is going to give me just the first element. Now, there is something else to keep in mind, that if you know another programming language, so keep in mind that the numbering starts from 1. Some programming languages start from 0, but here is starting from 1. Okay? Now we're going to go back to the slides. Here, so we did this. Oh, here are the comparison operators. Now you see here 7 not equals 8 is going to return true. This is uppercase, true. You may also use logical operators to create the compounding expression, like for example 7 not equals 8 and x not equals 2. Just an example. Now we went through this. Okay. So, this one, what this do, REV, it will just reverse the list. So if I have my list here, it will just put it in the opposite order. So this is what it does. But here, notice that I printed the output to the screen, but my variable z is not changed because I did not use an assignment operator. So this is important, right? I did not use an assignment operator, so my variable is not changed. And here you've got the sorting, and what else you've got here? So we did this. Now here, using help pages, it's a question mark, right? So you put a question mark and the name of the command that you want to look up, right? So for example, and we can even look up what the help command does. See this? It's a documentation on the help command. And here, what it's telling me here, see this, that's what I meant optional argument. Another way to call help is, you can do it this way. You can put help, and in parentheses you can type the command that you want to look up, and here it is. It does not matter. You can do double quotes, you can do single quotes. Now here, sometimes I could have the same function in more than one package. I could specify the package name, right? So this is optional. But if I don't specify the package name, it will still work, right? There we go. So one thing I like about R is that there is more than one way to do it. You can do question mark help, or you can put the command inside the parentheses as an argument to the help function. Now, we're gonna go back. So summary, I'm gonna show summary command shortly when we get to the data set. Now, here we go. I'm gonna show you how to change the working directory. And there is more than one way to do that. One way is, okay, so let's do it this way. We can go to session, and we can do it, set the working directory, right? And then you can say, choose directory. So now again, session, set working directory, choose directory. And what I could do is, I'm gonna find the directory on my hard drive, and it's gonna be, I have a folder that I created, and I have data sets in that folder. So I'm gonna do this, select the folder, and notice this. What happened is R ran this command on my behalf. So CETWD, and in the parentheses you specify the folder name, right? So here I have a /, but I believe in Mac it's going to be something different, but I'm a Windows 10 user. So basically right now my working directory has changed, and notice here this panel got updated. It's showing me the files in the current working directory, right? Alternatively, I could have navigated to the folder I want, and I could have clicked here, and there was an option here to set it as a, I click on more, and then there is an option to set it as a working directory. See this? So what I could do, this is not in the slides, but I wanted to show you that I could just navigate. I can use this up arrow to go up and down. I can browse here, and then I go more and set this as a working directory. There is more than one way to do that, okay? Now, here, if you notice that the title bar on the console window also shows what your current working directory is. So that's one way to find out, right? There is more than one way to do the same task, and see here it shows you. Now, here it shows you one way, set the working directory, that's what we just did. Here it's showing you how to get the working directory. GETWD command. This command is going to return what the working directory is. Right? I'm going to scroll up. Now, here, this is how you would read the files, and I'm gonna do that shortly. One way to do this is to just type the command, but another way to do it is to let R generate the command for you. So what I'll do is, now, this is a change in version 6.4, so you may want to write that down. Import dataset. In the older version, it used to say from text file. Now it says from local file. So write that down on the slides. You may want to take a note that it's no longer from text file, it says from local file. Okay? So I'm gonna do that. And now now notice that, where did this browse open? It opened to the folder that I set as a working directory, didn't it? Right? So now I'm gonna find my dataset, cars, for example. I hit open. Now here, what is doing, input file. So this is a preview of what I have in my CSV file, and here it's showing me the data frame is an object where the data from my file will be loaded to. So it's showing me the data frame column names, right? Which is usually, it's a name over here. ID, make, fuel type, number of doors, and so on. But another thing to keep in mind is that if your column name here has a space, R will replace it. I believe it's an underscore. Yeah. So make sure also that this is checked. If I check it to no, see what happens? R is not going to use my headings. It's going to name the variables for me. Right? This is what I don't want, because I have my headings in the first row and I want to use them, so I click this. NA, it means that my missing values are represented as an A. Now here, it's showing me that comma is a delimiter. See this? I have a comma that delimits the values, right? So that's how it knows here how to break it down. Oh, here it is, NA. Price NA. It means that the value of the price for this specific instance is missing, right? So now what I'll do is I'm gonna click import, and notice what R will do. Okay, I have to move. What R did, it ran two commands for me. The first command is to read the CSV file, and it created the variable name called cars. I forgot to show you that, but it's in the slides. when you import the data set, it automatically names the data frame with the same name as the variable name, but you can change it. Okay, so now view cars. What view command does is it shows me how my data looks like. So this is basically like a tabular view. Here it shows me how many data rows are, and here it displays the first 6 rows right now. And here are my variables, and what you could do, you could filter what you see here, and you can click on errors to sort your data. Oh, and see this? Here, it shows as blank cell. It does not show an A. It shows as a blank for some reason. All right, anyway, so now here, this is the name of the variable. Do you remember what happened when we loaded the data? And it's nice in the tabular format. And when you click here, it's even nicer. You get even bigger preview. I'm gonna close that. Now, suppose that homework is big and you're not gonna do that in one sitting. That's what you can do is, you want to save all your scripts in a file. I'll show you this. File, new file, R script. File, new file, R script. Here it is. Now, what you want to do is you want to take the command here and you want to copy it to the source file. So this one way to do this is copy and paste, but this is, I'll show you a different way. I'll go to the history and okay, so this command I knew it's working, and next time when I reopen RStudio, I need to set my working directory again, right? So what you want to do is, see this? To source. This will copy the command to the R script that you want to save, right? And now I'm gonna do this. I'm gonna do to source, and I'm gonna do another one, to source. So here it is, and now I want to save it. I go File, and I want to do Save, and you're gonna give it a name. I'm gonna just save it R practice. Now, where is it saving? This is what? My working directory, right? So this is very important. The working directory, this is where it's gonna save. Of course, you can always browse to another folder, but this is really convenient, right? So I'm gonna go here and I'm gonna go Save. And it's gonna save the file. If you later on, if you open this folder in the Windows Explorer, you're gonna see this file with .r extension, right? So when you come back to next time, you're gonna do File, and you're gonna do Open File, and you're gonna find that file. Now again, it opened the folder, which is it's set up as my working directory, right? So you're gonna open this file, and this is what you do to rerun one command at a time. You put your cursor on command, you hit run. See this? Run, run. Okay, so this is what you do when you come back to continue working on homework, right? So make sure you save everything, right? And you want to save it in a RAR script. So whenever you have a working version of the command, you save it. So now we're gonna go back to our slides, and an object, this is a data frame. An object where I loaded my data is called a data frame. And here it's basically showing you, it's telling you some rules for the naming. The variable name or the column name in Excel, it cannot contain the special, there are certain characters that it cannot contain, but it cannot start with this, right? The first character cannot be exclamation point, for instance, right? So this is just some of the naming conventions. Now we went over this, but here take note, it's not going to say from text file, it's going to say from local file. Now, this is what I meant by, this is a data frame name. By default, it's just going to grab the file name. Sometimes you want to change it. If the name is very long, for instance, you want to go ahead and change it. And here we went over this, but I'm gonna show you what iris is. I went over what view command does, but I'm gonna show you what iris is. Basically, the RStudio installation comes in with some data sets, and iris is one of the data sets that comes with RStudio installation. Now, I could do this views, but here is view. Now, the first letter is uppercase, okay? Very important, the first letter is uppercase. And I'm gonna type iris, just to preview my data. Here it is. So this is the data that comes with our installation, and it has 5 variables. Those are the flower measurements, and here is a species. So here again, it's my preview window, and I can sort the data, and I can open it in a different window, I can filter it, and so on. And another helpful thing here is that suppose that I want to read more about my data set. If I put a question mark and type the data name, here it is, it's showing me information about the data set, but this is only about the data sets that come in with R. And here is the package name. It's in a package called datasets, right? This is where my iris data is in. Now, I previewed the data here. Another way to do this is the command called head. And what you do is you just type the name of the data frame. In this case, it's just iris, head iris. By default, it's showing me the first 6 rows. If I want to change it, I'm gonna add the second input parameter, which is number of rows. Now, suppose that I'm very lazy, I don't like typing again. I hit my up arrow, and it's gonna display the command that I typed last. So now I'm just gonna add, I'm just gonna put 10 right here. And it's gonna show me the first 10 rows, right? So this is one way to preview the data. And also, suppose that I want the last rows. To show the last, I'm gonna do the tail and do iris. That's gonna show me the last 6 rows. But again, I can change it, I can do 5, comma 5. This is gonna show me the last 5 rows here, right? So basically that slide, it goes over this viewer, but it's using iris data. Okay. Now, so what I'll do is, here's our next slide. Oh, here it is. It's showing the head command that I just showed you. And here are the variable names. Data row labels, for some reason, if you notice that, it's just labeling the rows for you. And here, oh, see this, there is a dot, right? And another thing is that notice that if right here, if I have the variable name, the first letter is an uppercase, when I type it, when I refer to it in my code, I need to make sure that it's an uppercase. So, for example, right here, I was showing all variables, right? But if I want to see just one, what you do is this, iris. If I want to see only one variable, I'm going to put a $sign. Oh, and a nice thing is here, I have a pop-up, and it gives me a list of variable names. So this will list the values of sepal_length variable for all instances in the data set. So what this number means is that 5.1 is for the first one, for the first flower. 5.7 is for the 19th flower. So basically the label here is a row number corresponding to the first value in here. It's just how R displays, it just wraps it for me. Okay? So it goes the data frame name, $sign, and then the variable name. But let me do this on purpose. I'm going to do this on purpose. I'm going to type lowercase l. What is it going to do? No, because this is not defined. There is no such a variable. That's what it's showing me right now. Right? So if you get this error, it's because this variable does not exist. Another way you could do, names command shows me the names of my variables. If I'm not sure, what I do is I put my data frame name in the parentheses, and it's going to give me all my variable names. So if for some reason the pop-up feature does not work for you, you can just copy-paste the variable names here, right? So there is more than one way to do it in R, and that's a part that I like. Okay, so now we went over this, we did, oops, for some reason, oh, we did not do, okay. So I showed you how to get the variable names. I'm going to show you what attributes command does. It's just going to show me the properties, basically. It's going to show me the properties of my data frame. See this? It's because I mistyped. I mistyped the command. That's why it's showing me an error. It's a double T, I think. Okay. So here it is. What it does, it shows me the structure of my data frame, right? It's showing me class iris is a data frame, and here it's just showing me the variable names and the row names. In this case, the row name is basically the row number. So str command shows me the structure. Alternatively, I could go here and I could expand this. But here I see more information actually. For each variable, I see the data type. So what it is the factor variable, it has a set of predefined values. Like for instance, make, right? It's a car makes. I have a set of valid car makes which are defined ahead of time. Fuel type, diesel or gas. It's a discrete value, and we know what the values are ahead of time. And this is a numeric, length. It's a number because we don't have a set of predefined values, and the values such as width, they can be real numbers, and there is no minimum in this case, there is no maximum, and we don't have a specific set, like for instance here, front or rear, right? There is no east, for instance, or west. Those values are not valid. We have a predefined set, and the way R calls it, it's R terminology, level, right? It calls it level. So this is a car data, right? Yeah, that's a car data frame that we loaded earlier, and it's showing me each variable that I have, and it's showing me the data type, and it's showing me the number of variables, here, and the number of observations. And what you could also do is, you're going to like this command, summary, and then what I do is I just put the data frame name, and this shows me the statistics. Now, here it is. This illustrates the difference between factor variable and the numeric variable. Fuel type. See this? It's going to show me the value and how many instances have each value. Here, number of doors, same thing, right? And here, this variable, it's a numeric. It's going to show me the minimum, first quartile, median, mean, third quartile, and maximum. So for each data type, the statistics are going to be different. NA, this means that I have 2 data rows missing the value for HP. Now, you may or may not have noticed it says other. Some factor variables have more than 6 predefined values. What it does is it shows the counts for the 6 dominant, and it groups the remaining values under the category called others, right? So what I could also do is, suppose that my data set is huge. it has 200 variables. And I want to know only the statistics for the price variable. Am I going to run the command on the whole data set if I have 200 variables? Of course not, right? What I can do is I can do this. I can do summary, and I'm going to put this cars, and then I'm going to put a $sign, and I'm going to do price. So what you do is if you type the first letter, it's going to give me, here it is, and I hit the enter key. So now it's showing me the statistics only for one variable, which is price. I also have an option to show only one statistic, right? I have to change this to mean, to show only one mean, only the mean, right? If I don't want to see everything else, I want to see just mean. Oops, it showed me NA. It's because I misspelled. It's because my spelling is bad. But anyway, so you know, if I'm not sure, I can do this. Here it is, mean. I spelled it right, but anyway, I'm not sure why it not found it. It should have, but anyway, the idea is you can only type, you can find one statistic, or you can do the summary command. It will show everything, or you can do summary to show the statistics for all variables. But again, if your data set is huge, right, you have an option to show just one variable at a time. Now I'm going to switch back to slides to make sure I don't miss anything. Yes, did I have a question? No? So this slide is about the data types. We did that. Okay. So basically, the class command is just going to show you the variable data type. For instance, iris is a data frame. IsNumeric is going to check if your variable is a numeric. It's going to return true or false. Now we're going to continue. str command shows you the structure. And we went over the summary command. And we went over the summary command for one variable. Here it is, that's what I meant. Mean command, it's going to show you the average for one variable. Unique, it's going to show me the unique values of a factor of a variable. But again, remember, there is more than one way to do it. You can type levels command, or you can type unique command, right? And here is the standard deviation. Standard deviation is not included in the output of the summary command, but sometimes if you need it, you can just run this. Right? So now this is just basically you can run fix command and put data frame name, and it's just gonna open editor. You can just edit data, but again, this is only useful when you need to change just one value or two. But if you want to change the whole variable, this is not a good way to do it. You want to run commands to do it. It's basically here it's saying that you can rename your variables in the editor. Now, suppose that I want to delete the variable. One way to do it is just to set it to null. So here it is. I can just do Ctrl+C. And I can paste it into editor, and I want to set it to null. Here it is. There we go. So what it did is it removed the ID variable. So in some methods that you run, you want to remove the ID because it might not be relevant to an analysis that you're running, and also because the method speed, right? So you're gonna see it later on if you run more complicated method in the upper level courses. But right now, let's go back here, make sure I cover everything. Now, here what it's saying is that it's another way to access the different elements of the data frame. Like for instance, suppose that we have an iris data, right? What I was doing earlier, I can display, if I do this, it's going to show me all data. I don't want that, right? So what you could do is you can create a subset Now, each element in the data frame is referenced as a row number and column number. This is something similar to a battleship game if you've played. So each element has a row number and a column name, right? So if I do this, if I do Iris, for instance, Iris, and in here if I put 3, 2, oops, it's because I have to put the upper. Okay, I see what I'm doing. I put dot instead of comma. But if I do this, right, what it did is that it returned it in the third row, right? So third row and the second column. Yeah, that's what it does, I think, yeah. So basically what it does is it basically returns it returns the element. I'm sorry, my mistake, it's here. Third row, second column, that's right. See this column 1, column 2, row 3. It returned one element for me. Now, if I want to return more than one element, right? Suppose that I want to return rows 3 through 6. So where I do this. It's going to return the rows range, right? It returned this guy right here, 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 and here, right? What I could also do is I can do this. So this returns me the sepal width, sepal length, and here it's going to be rows 3 through 6, right? So every element, to reference one element, it's a row number, column number. Now, another thing I wanted to show you is that suppose that I want all columns. So here, if the number is omitted, it's going to show me all columns right here, right? So that's one way to do it. But there is more than one way, but this is one way. Now I'm going to go back to slide to make sure. So we did the subsets. Here, basically, it's showing me it's one way to get rid of the rows that have no data. So I can create a new data frame called new cars, and command NA omit is going to remove every single row that has at least one missing value. And this is another way to, this command is going to count the number of rows that do not have a missing value. So again, here what it's doing, it's subsetting. Instead of specifying the explicit number, I can specify the condition in here. That's right. Instead of specifying the specific number, I can specify the condition. That's what it's doing basically here. Back here, yes. So here it is. It just, oh, this is very interesting. What's happening is here, the missing values, they affect the mean function. It affects what mean function returns. Like if I do this mean, hopefully it will work this time, mean. And then I'm gonna put my cars, and I'm gonna put the variable name, which is HP. See what it does? It put NA. I'm expecting to get an average value, but I did not. Why? Because my variable HP has missing values, right? And this slide here, it shows you the solution. You can do NA.rm equals T. What it does is it computes the mean, but it's going to overlook the missing values. Okay? So this is an optional parameter. It says optional. By default, it's false. So see this? Now it's computed. Okay. Now what we'll do is we're going to go next slide. Here I'm just showing you how to sort. Right? You can sort the data by the specified column. and here, notice that what it does here, it's telling me that I want to pick all rows. No, yeah, I want to pick all rows, but I want to sort it by this column. That's what it does. Okay. And here, what I do is I create a new variable that stores my ARIS data sorted by the column width, by the column name, sepal width, and then I'm previewing the first 10 rows. That's what I'm doing. But here it is. Notice that a row number is 6163. This is the row number in the initial copy. It's an initial copy of the ARIS data that I took, right? And here, order function is going to sort this, right? And here, it's going to take a subset. It's going to pick all rows, right? It's going to pick all rows and every single column, because I don't specify which column I want to pick. And notice here, you can nest functions in R. It will make more sense to you when you start actually practicing. R takes a lot of practice, so... And, oh, this is also nice. The table comment, you want to see the frequency counts, right? So, for instance, table, iris, and now here I'm going to put species, right? What it will do is create the frequency counts for my species. And what's nice about it is that I can use that to create a pie chart. The pie chart is created, the command name is pie, okay? And that command takes this guy right here as an input. So the pie chart command takes this table, which produces the frequency count as an input. So I have this, and in here I just can copy paste. I did copy paste. There we go. So now here it is. This is my graphic. Right? So what I could do, what I was mentioning earlier, I can do it. I can save it as PDF. I can copy it to the clipboard. If I want to copy it to the Word file, my assignment document, I can copy it to the clipboard and then I can paste it. Or I can save it as an image file. And also sometimes the graph can look, the plot can look a little bit cluttered, so what you can do is you can click on zoom, right, to get a better view of this picture, right? So now you've seen the table command. Table produces the frequency count. This is only for the categorical variables, and then you can do the pie chart, and notice that R selected the colors for me. If I wanted to, I could specify. So you would do is you would run the pie command, !pie, just to see more options that the command takes. And there are some examples here. So see this? I showed you list earlier. This is an example where it's used. I want to use different color codes for each slice of the pie chart. So what I do here, I create a list of colors and I pass it here into the pie chart function. Here it is. So this is one application of the list. Some function names take a list as an input. And here it is. Here is another one. Yeah. So here you see examples of how this function is used. So this is your best friend, the help here. Right? So as you're working on it, you have this tab, and you can look up the commands that you need help with. Now, what else do you need? So we did this. Here it is. Installing a package. Some packages do not come with our installation. For example, a rules. So you just type this command, installed packages or rules. Okay? Or you can also use the interface. You can just do, I believe, with tools, install packages, and then you type your package name. Now here, this is very important. Since you cannot really save anything to the folder where R is installed, the package is going to be installed as a local library. When you install the first package, it's going to prompt you, and you need to select yes. on the first package installation, it's going to prompt you if you want to put it in a local folder. And then it's going to create this folder for you, okay? I'm going to hit cancel. And another important thing is that here is a list of packages. If anything that, any package that you installed, each time when you restart R, and if you need to use that package, you have to load it into memory. And one way to do it is just to click this checkbox, and this is a command that R is going to run on your behalf. Okay? So that's one way, or you can just type the command. But this might be a little bit simpler, right? Okay. So we went over installing the packages. Now, this is how to load the package. I just showed you this. Now here, this is showing you how to do the scatter plot. There is a plot command, but here, if you put two variables here, sepal width and sepal length, right? So I'm gonna copy this, and I'm gonna copy this here, right here. Plot. So what it does is, it creates a scatter plot, and here is my x-axis and the y-axis. Now, some of you may know that it looks ugly, yes, and you can change the x-axis name and the y-axis name, and I'll let you guys play around with this. But to get this, to find out how to do this, you're going to type the help command, and here it's just showing you the different plot types that you can do, and it's showing you, see this xlab? This is a title for x-axis. Right? So, oops. What I could do is I could just do this. I could put comma. I can type xlab equals to. I'm just going to type something just for practice, just to show. See this? It just changed to what I want. So you're going to read help, and you're going to go with the help pages, right? As I mentioned earlier, you need to read the help pages when you use R. Now here is just a histogram, and here again this is a list, and what that will do is it will repeat the colors, it will cycle through. So once it reaches the blue, it's gonna go back to red. So if the list is not big enough, it will just recycle it. I showed you the pie chart, but here I'm using the car's body style to build it, but you would do it the same way. Right? It takes table as an input. Now I showed you how to save the files. And now what we're gonna do, well, I'm just gonna show you to exit RStudio. You can just select exit, or you can select quit. Right now I'm gonna show you the linear regression. As you may have noticed, it's part of your assignment. You may or may not remember that back at high school or back in the algebra class, when you used the graphing calculator, you had a problem where you had a bunch of points, and your task was to create an equation of a line that goes through the points. You may or may not remember it, where you have set of points, and the task was to create a line that goes through the points, or closely goes through the points. And then when I have a new point, new x value, I can plug it in to my equation and get the y value. There is something similar that we're going to do here, except you're going to have not just one variable, you're going to have multiple variables, right? You're going to have multiple variables, and you're going to create, well, it's called hyperplane instead of line, because it's in multiple dimension, and you're going to create an equation to predict your dependent variable, and it's going to be intercept plus the product of coefficient and the value of each independent variable. Let me load the data, or actually I think I have the code open here. I have the code open here. Yeah. So what I'll do is I wrote the script. I wrote the script to run the linear regression command on cholesterol dataset, and you're going to learn more about the linear regression in the upcoming 2 weeks. and there are going to be videos posted in the classroom for you to watch. But what I'll do right now, I'm going to read the data. I hit run. What I did was I just read the data, and it has 303 variables. It has 303 observations and 14 variables. And what the data set collects, it has the data on individual vitals, such as blood pressure, age, sex, and so on. And we're going to predict the cholesterol level in individual blood, right? So basically, if I have a new data row, where I know all of this, besides cholesterol level, I want to have a function where I can plug in all my independent variables to get the value of dependent. This is my task. But the way it's done is that I'm going to split the data in two parts. I have the first part of the data I use to build this model, and the second part of the data I use to validate the model. Now, the splitting itself is going to split randomly. But when I come tomorrow, if I want to rerun the method, since I'm not going to be able to do this assignment in one sitting, to be able to rerun method and reproduce the same result, this is a set seed command. And you're going to have the files, you're going to have the file with commands. So what you will do is you will just replace, you're going to put your dataset name here. Okay? You're going to put your dataset name in here. So what I'll do is, right now I'm going to run the next command, and it's going to preview my data, right? So I'm going to go back to my file. Now, here you notice the hashtag. This is a comment. Comment is not executable line of the code, but what it does is, suppose that tomorrow I come back and I want to know what I did. So that helps me know what I did. Or if, for example, if Steve borrows my script and he wants to add something, he wants to know what I did, right? So it will be helpful for him if I put comments. Well, this script is relatively simple, but what if I have something really complex, right? So that really be helpful. So now what I do is I'm going to hit run, and I'm going to just run this, and it split the data into two parts. I'm going to use this part, training data, to build the model, and I'm going to use my test data to check how accurate my model is. So here it is. That's called formula. Basically what it does is, on the left-hand side, I specify the variable that I want to predict, which is cholesterol. I put tilde and I put a dot. Dot means that I want to use the rest of the variables as predictors. If I wanted to use only few of them, I would have to explicitly list them. But here, if I want to use all of them, I just put like this, right? Run. And here I'm just going to do run. So what it did was, it created a model on the training data. Now here, there is more than one way to do this. You can do print model, or you can just type model at the prompt. Right? So this is showing me the coefficients, right? It's showing me my coefficients, and it's an intercept. So basically what it did is, it created a line in multiple dimensions. That's what it does. And you're going to learn more next week, but I'm just basically giving a preview. And now here, what I could do is, I could do the prediction. What I do is, the predict command, it takes the model that I created. I created a model, and I stored it in a variable called model. And I'm passing the test data in here. So what I'm trying to do here is, I'm trying to predict, I'm trying to see how accurate my model is, right? So I'm just going to run, right? And now what I do here, I'm going to do a plot. And I want to plot, so here it is, where X value is an observed value, which means it's an actual value, and this is a prediction, it's an estimation. So my goal is to estimate the cholesterol level, and upline, this command is going to add a diagonal. So basically, if my point lies on the diagonal, it means that my observed value, right, the actual cholesterol, is equal to estimated cholesterol. Of course, we want the points to be closer to the line as possible, but we need to keep in mind that not all relationships are linear. That's something to keep in mind, right? In this class, we're covering just the linear regression, but in general, keep in mind that not all relationships are linear, because this could be, the point could lie on a parabola, it could be anything else, right? And the step function, you're going to learn about it next week. What it does is some variables here can be significant, some not. It will produce basically the reduced model, right? Here it is. So basically just telling me that these variables it's going to keep, and it removed some variables that the method decides are not significant. And here, actually, what I could do is I could run the summary command, and I'm going to put the first model, and I'll show you something. Okay, here it gives me more information. It's showing me residuals. It's basically the square difference between the actual value and predicted values. And basically here, so it's showing me the coefficients. This is the intercept, right? So remember, when you have a line and a plane, intercept is a point where the line hits the y-axis. So here you can say intercept is a point where the rest of the independent variables are zero, just so to speak. This is a coefficient for the age. It means that if I increase the age by 1, while I keep the rest of my variables the same, but if I increment my age by 1, this is how much the cholesterol is going to increase. Okay, this is what it is. That's what it means. If I get 1 year older, this is an increase in my cholesterol level, right? But notice this, couple dots, 3 dots, it means that this variable is significant. See this? This shows the significant coefficient. But again, this is a 95% confidence interval, right? So, but if you notice that when I did the step to produce a reduced model, yes, it kept the sex, it kept the age. Yeah. Now, here you may notice that some of the variables are categorical. So CA variable, for instance. What it means is that if CA variable is 0, we add 11.368, etc. We add this number to the cholesterol level. If CA is 1, this is a number that gets added. If CA is 2, this is a number that is subtracted. Right? So the cholesterol is lower by 1.27 if CA variable has a value 2. That's what it means here. Right? So in your assignment, you're going to do the model with all variables and you're going to do the reduced. Yeah, but notice this. This is a formula, the new formula. If I wanted to use only some of the variables as independent variables, I would have to do it this way. Dependent variable name, tilde, and then I would have to list all variables that I want to use delimited by the plus sign. This is how you would do that, right? So the step function, it runs through, and at each step it eliminates one of the variables, right? So that's my final model. And you would probably want to compare the final model with initial model, right? So yeah, that's what you're going to do in an assignment. Yeah, but I know I've been talking a lot, but let's see if we have questions. I want to see if you guys have questions. How many people are still awake? If you don't have questions, I do. Then I will ask question. What's very important when you type commands? What do we need to keep in mind? Anybody? For instance, if I type the command view, if I type lowercase view or uppercase view, it's not the same, right? We need to keep in mind that R is case sensitive. Yes. Excellent, excellent, excellent. R is case sensitive. Excellent. Now, if I'm not sure what the command does, what I'm gonna do? Excellent. You can type a question mark. Excellent. So you can type the question mark and you can type the command name. For instance, head. Yep. So this is your friend, right? You can just type here the command name, and it's gonna show you how to use the command. So this is really nice. As you're working, you have this open, and you can. Sometimes it's a little bit of trial and error. And another thing is if I click on a package, for instance, it's gonna show me the help page for that package. It's gonna list the methods, and then I can click and drill down, and I can see the method, what that specific method does. I can navigate between help pages right here, right? And the plots, see now I have two plots. I can use the arrows to navigate between my plots. Yeah. Now remember, upline command adds a line. And I did it because I wanted to compare if my predicted cholesterol or estimated cholesterol is the same as the actual cholesterol, right? Oh, and another thing that I have in there is I put some web pages that you might find useful. There is a lot of web pages, and there is a question and answer forum. Sometimes suppose you're unable to find something, and you can go into that forum and see if another developer already had that question. There is some interesting cheat sheet that you may want to. Some people prefer to print them out and have them in front of them as you're working on an assignment. For instance, if you're not sure how to take a subset, R Quick Reference has a list of important commands for you. And these are I showed you this web page, right? It's a web page where you install the RStudio, and there are there's a variety of tutorials and so on. And actually, a lot of the developers they develop their own code and they share it on the GitHub. So as you keep learning it, I'm sure that eventually you might be interested in downloading the packages that other developers wrote, and maybe even writing your own packages at some point, if you're interested. Yeah. So now let's see questions. I would like to see questions. And you guys know where to find me, right? If you have questions, you can email me, right? So I want to see questions. Oh, what is my email? I'm gonna type it here, I guess. Yes. Okay. Just for fun, I can do this. I create a variable called Yelena, and I'm going to set it to this is a string. So what it did was it created a variable called Yelena. Well, this is I just did it just for fun. So this is my first name, last name, and at faculty.umec.edu. That's my email. Right. Sure. And I want to see more questions, guys. I'm sure that you will have plenty next week when you start doing it, but the key to success is practice, 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 practice. That's how you learn, right? And you start early. You want to start as soon as you're done with your assignment that's due this week. As soon as you're done, you want to start because it takes some practice, right? Anybody? I've seen some. What's that? I'm sorry, what was that? I do not really see the chat screen. Might I ask you to say what the question was? Oh, the graph. Oh, thank you, thank you. Yes, yes, yes. Yeah, but you can this I just use the basic. Yes, I use the basic plot function, but also for the charts there is a more advanced package, the ggplot. If you're interested, there is more advanced, but I use the basic functionality. Yeah, and you can even add colors. You can do a lot of interesting things, but to get started, I wanted to show you the basics, right? We want to start from the basics, but then we keep growing as we go, right? And I could add my title, I could add labels, I could add the color code, and sometimes there are cases when you want to add a legend. So it's really a lot what we can do, but we're just starting. In this class, it's just an introduction, but in advanced courses, there is a lot of exciting stuff. Arsim. Oh yes, I agree with you. R has a lot of functionalities, and in fact, developers they build their own packages. I'm not surprised if every day you have a new function out there. All right, and you would want to keep updating it, so you want to make sure that your packages are up to date. So you want to do this, check package updates. I do mine like every week, is it? So it showed me. I'm not gonna do it right now, but what I would want to do is I would have to do this select all, and then I would have to hit install update. I'm gonna hit cancel for now, and I'm gonna update it later. So basically, you'll need to keep updating your packages. Yeah, and recently I had to upgrade the RStudio version as well. You check for updates. Oh. And definitely, it's a lot of packages. There is more than one way to do something. So if I give you a problem, perhaps, right? I'm gonna do it one way, and your classmate might do it differently. It's possible. Yeah. So I want to see questions. Is there anything that I said today? Well, a lot of it will make sense as you practice, but I want to see if you have I want to see what questions you may have, so that way we want to make sure that you guys are all set to start working on assignment. And we're gonna have this recording, so sometimes it might be helpful for you to watch it again. Even if you're able to attend, sometimes you may want to watch certain sections of the recording more than once. Trust me, sometimes you want to watch it more than once. So, any questions? Steve, do you have anything to add to what I covered?
No, I think it was very thorough and a good start. As you said, I think the key is, of course, practice, practice, practice. Try things. Spend that first week trying lots of things. Don't try to build your assignment. You know, you've got 2 weeks for the assignment, so don't try to build it the first night. Learn the software, try some things, start simple, start small. Try to duplicate what Elena's done tonight with her little practice problem, and then select yourself a good data set when you're ready. But don't rush into it. Really give yourself a chance to learn. I think that's important. As she said, you really learn R best by just getting in there and trying it. Okay, I'm going to go ahead and stop the recording. And of course, that means that we'll